Okay, so now let's go over the question again. Okay, let's start from scratch over here. So for this particular question over here, does the caching of the old expression here happen right after the syntax checks? So this question here, I would say it's not really phrased properly. So I want to be a little bit picky here. Okay, so what's not really accurate over here is, does the caching have right after the syntax checks? I would say no, not so precisely. Okay, so the precise way to think about this is, so given any routine that you want to execute at a runtime, so you know the routine might have some precondition, you will have the implementation, and also you will get a post condition, right? So you may have some Boolean expression over here, you have some Boolean expression over here, and also you have some instruction over here, right? That's usually the three components you have. Okay, so now in order for, let's say what's going to happen at the runtime. At the runtime, we are first going to check over here. We're going to check the precondition first. If the precondition is not satisfied, of course, it's going to be a precondition violation. That one is pretty straightforward. Let's say if the precondition is okay at the runtime, right? So that means what we're going to do is we're going to execute the implementation from the supplier. So we want to see if the service will be satisfactory or not. Before we do that, because we know that later on, we're also going to evaluate the post condition, but the post condition might involve the old expressions, in which case we have to be careful. Any old expression over here should be cached beforehand. So if we got any old expression over here, and then if you got any old expression over here, so it might be checked later, right? So that means you better memorize or cache that beforehand over here in the pre-states. So in that case, right at this point over here, we're simply just going to memorize all the old expression values. And then after executing the implementation, we will be able to use them to check against the post-state value. So that's a very quick recap from the lecture. Okay, so syntax checks, this one is not really the case. It should be after executing the precondition at the runtime. Okay, and then the next two questions over here, question number 2 and question number 3, they are really about why that particular example that we talked about in the lecture, why would it not compile? That's really the question. Okay, so now if I switch to this particular slide here that's familiar to you, let me just explain one more time. Maybe whoever is asking this question might be still wondering about why it wouldn't compile. Okay, so now let's say this. This is our command, the updates, right? It does not have any return type over here. And then we have the implementation here. And let's say there's no precondition, right? It's unconditional. It can always be executed. Now, let's say at this point, right before we try to execute the implementation, right before that, the I for runtime is going to look at the post condition here. In this case, there's only a single post condition, only a single one. So what it will do is it will try to see what old expression must be cached in the pre-state at this point. So you will look at that. This is the old expression over here. And the old actually applies to this particular call to the get over here, right? Calling the get is okay. However, the problem is actually referring to j.item, and j only exists in the post states over here. So now at this point over here, if you simply try to write the remember how you actually cache the value, you simply say something like old, maybe get j.item is assigned to over here old. Oh, don't have old anymore. Okay, just this particular expression. Let me highlight it. Just this one here. So that would be simply get j.item. So now you can see over here in the pre-states, j simply doesn't exist at that point. So that's why this wouldn't compile. So there will be compilation error. And how you fix it, we talked about already in the lecture, unless you have a problem with it. All right. Okay, so far no question on the chat. Okay, let me see this. Okay, so now let me go on with this. Okay, so there's another question on the Google Doc. Okay, so this one's interesting. There are two parts of the question. Okay, so part number 1, we're just going to see this. So if you remember, this is the fix that we did in the lecture. Okay, that's the fix. And now your colleague is wondering about, what if we try this fix instead over here, the pink one. Okay, so now here's a question for you. If we actually do the pink one as the fix, would it actually compile? So that's the question. Would it still compile? Anybody? It's a yes or no question there. You don't need to explain. Just yes or no.
Sorry, Professor, can you repeat the question?
Okay, you want to, sorry, speak up a little bit louder, please.
I'm just saying, can you repeat the question?
I can repeat the question, yes.
Thank
so in the lecture, we said this will be how you can fix it, right? Remember, as in the lecture, we said this wouldn't compile. However, one way to fix it would be you simply use the brackets over here, and then you say old current deep twin. So this will make it compile. Okay, good. So that's what we said in the lecture. So now the question is, if I try this particular new fix, which your fellow student proposed, if I simply tried it, I say old current deep twin get item, get j.item over here without any parentheses, will the pink fix over here compile or not? Yes or no?
No.
I heard no. Okay, why? I have deep twin.
Because of the, I guess, parentheses, the meaning of the whole expression changes. So
okay, you want to be a little bit more elaborate? Yeah, you're on the right track. You want to be a little bit more elaborate here. Let me let me guide you a little bit. Okay, so if you think about the green one over here, we know that for the green one, the old expression basically applied to only current deep twin. So that's why if you try to cache this particular value expression over here in the pre-states, that will be okay, because current always exists. Okay, so that's why the original fix was okay. So now, why would this new fix not be okay without the parentheses? You want to try again?
I guess because the J still doesn't exist.
Oh, yet. Okay. It sounds okay. That's good. Pretty good. Yeah, I know exactly what you mean. But that's because you can see the old keyword over here applies to this entire expression over here, right? So in that case, it still includes j.item. So that wouldn't actually work, even though you got deep twin. So having deep twin has nothing to do with whether you can fix the compilation error, because the root of the problem is that you refer to j.item. So j.item should not be referred in the pre-states. That's correct. All right, good. For those of you who might need to a little bit more written feedback, I'll say this. For this fix over here, this is the expression to be cached in the pre-states. However, it still involves this particular j.item. Okay, so this one still doesn't exist. So it will be still compilation issue, compilation problem. Okay, so guys, my feeling so far, the question you guys put on the Google Doc, I wouldn't say they really seem to me you got very fundamental understanding issue as far as I can see from the Google Doc. So hopefully the lectures are clear enough, and it's just about some minor details you want me to clarify. That's my feeling, right? Today is the last chance for you to ask me. So yeah, if you got any follow-up question, please feel free. Okay. Let me read through a little bit. Okay. So now I have one. Yeah. So another correct response for Nora. So that's right. J is still going to be cached. That's why it's not going to compile. All right. So let's move on. So this is actually a new question from today. So I just added before the meeting. All right, so now let's see another one here. That one is a minor typo. Maybe many of you actually noticed that when you saw the lecture, okay? If you recall from the lecture, I forgot which part. Maybe it was lecture, is part 1A or 1B, I forgot. But anyway, let me just mention quickly. So somewhere in the middle of your lecture number 2, I try to compare the iPhone version versus the Java version. Okay, let me just highlight just once more quickly, okay? Remember in week number 1, when we talk about the final version of the Java, right? Especially how we check the post condition. The way you have to deal with is, number 1, you have to manually declare a local variable here, just call it O balance, right? So you cannot just use the old expression and let the compiler or the runtime to automatically handle that for you. It's not possible, right? So in Java, they don't have such automatic mechanism for you. So you got to do it by yourself. Now the problem is this mechanism wouldn't scale. For example, if you have a very realistic application whose post condition is pretty complicated, which involve many variables, in that case, you have to declare so many variables manually yourself. So that's not the way to go. You want things to be automated as much as possible. So now if you look at the post condition over here, so now we can refer to the O balance over here. You can think about this O balance is referring to whatever pre-state cache we did manually, right? So we can say this balance will just be the post state value will be O balance minus amount. So that's the exact relation for withdrawal, okay? The typo I made was hopefully just notice that, okay? So withdraw in the case of IFO, we can say current balance equals O balance minus A. It should be minus A. I didn't say that. In the lecture, could be that I kind of ran out of the space because I was around the boundary. That could be why. Okay, so a quick clarification for you. All right. All right. Any questions so far? Okay, everybody's good? Okay. Let me move on to, okay, this will be very interesting question here. Okay, I try to make it more like a exercise so we can interact with each other. Okay. Now, let's see now this. The question goes went like this originally. Very general question, but I want to make it more concrete for you. When would reference copy be appropriate? Because I think I mentioned somewhere in the lecture, I say, as far as the programming lab exercises are concerned, it would be safe to always put deep twin. However, as at a conceptual level, you really want to understand when you should use what. If it will be sufficient for you to use maybe a reference copy, you should only use a reference copy. If it does require a shallow copy, you should do a shallow copy. So if deep copy is not necessary, you shouldn't write it, right? But for the lab exercises, you can use deep twin if you're not sure. But that's not very a very proper mindset for engineer or scientist. We want to do things only when necessary. Okay, so now I created one example for you. And then that one day is going to use reference copy and also deep copy. Let's see, if we only got one but not the other, can we actually catch all the possible errors? That's something I would like to discuss with you. Okay, so now let's say this. Let me just go over the ultimate version together with you, and then I'll create some intermediate version, and we'll discuss what the problems might be. Okay, let's say we got account over here. Just make it very familiar to you. And then let's say we got owner of type person. Let's assume there's a person class somewhere that's defined. And then we got withdraw. Okay, it's a command. And now ultimately we want to have ensure having two parts for the post condition. Okay. Part number one, we want to say for withdraw, you shouldn't change the owner. So owner should be just the same owner as before, reference wise. So we're talking about the same owner objects. So you can see apparently for this old keyword over here is going to be a reference copy in the pre-states. Agree? Okay. The other part of the post condition will be not only that it should be the same owner objects, but also the owner's contents shouldn't have changed, right? So now, for example, when I say owner's content, maybe for example they imagine that balance does not belong to the owner. Okay, it does not belong to the person object. So that's why the person object should remain the same. Let's say maybe the person object contains, let's say, name and also maybe some address or maybe some like a membership ID, something like that. So those information shouldn't be changed by just a withdraw. They should remain the same. So that's why you can see I say owner tell that equal, assuming that the person class already redefined is equal. Let's make that assumption. Tell that equal old owner dot deep twin. Okay, so now we got two post conditions over here, right? I'll pause a little bit. I'll let you read very quickly about these two post conditions, and then we'll start with our exercise. Okay, so what I will do is, so now hopefully you're familiar with the two post conditions. Let me create two versions of the account, and let's see why we will need both post conditions, but not just one of them. For version number one, what I will do is, let's assume we only have this particular post condition, only this, okay? Only this. And then for now, just to really make it very explicit, I'm going to simply cross this out. Let's say we don't have this particular post condition. We don't have it, let's say. So that's version number 1. Okay. So now for version number 1, let me tell you what kind of error this particular post condition is capable of catching. And then my question to you later will be, what kind of error can this particular post condition miss? Right? Fair? Okay. Let me say the following. Okay. What kind of error can be caught by this particular post condition? Okay. So now same person is saying owner should be equal to the address of the old owner, right? So now if the implementation is actually going to, for example, to assign this particular owner objects rather than pointing to Alan objects, it might be simply pointing to just another person objects. In this case, it's going to be caught. Okay, everybody see it? Okay, let me be a little bit more precise over here. So what I'm talking about is this particular post condition here is able to catch the following wrong implementation. If the wrong implementation goes like this, for example, you might say after the withdrawal, whatever withdrawal you're going to do to decrease the balance, you might say the currents, you might say the owner, right? Owner is one of the attributes over here, right? You might say the owner is simply assigned to maybe just create a new person, okay? Create anonymous objects. Create person over here dot make. I'll just make some arbitrary, let's say Mark. That's what you would do, right? So now we have to convince ourselves if the wrong implementation will always change the owner to somebody else. That's very dangerous, right? It should be a very malicious, operation to do that comes with the withdrawal. So why can the current post condition over here catch that? I'll go over this with you, and then I'll ask you another question. Okay? The reason that this can catch it is because this. When we, right before we try to execute this particular wrong implementation, again, at the runtime, we're going to see that the old expression that we need to cache at in the pre-state will be just the owner, right? So what we'll get is, in the pre-state, we're going to say old owner is now just going to be assigned to just the owner. And the owner is simply just this particular error over here, right? So you can think about old owner is now just going to point to this particular person objects, right? So that's so good. So that's a caching process. And now let's say we go ahead and execute this particular wrong implementation, which is malicious, right? So that means now owner over here, rather than pointing to Alan objects, it is now going to point to over here just another object over here. Okay, so now it will be person. And then that one there is going, let's say we have name and also other attribute as well, right? And then we'll simply get Mark. Okay, so now as soon as you have done this, when we try to check this particular post condition over here, is it going to be true or false? Hopefully you can see it's going to be false, right? Because now when you actually compare this particular expression, when you say owner over here, owner is the post state value that is pointing to this particular object. So this is a red object over here, right? The red. Let me highlight it to show you. So the pink one is owner, okay? On the other hand, when you say old owner over here, the green one, the old owner, so that's a pre-state value. That one is really pointing to this particular person object. So the green and the pink, they're different objects. Apparently you have changed the owner objects in the withdrawal. So that's not acceptable, right? So this will actually give you a post condition violation as expected. So that's a good one. So it's going to be a post condition violation. And this is a good thing. Okay, any question about the good side of this particular post condition? Any question? Yeah, so you should always try to wear different hats. So when you're designing your post condition there, you're wearing more like a specifier's hat. You want to think about what kind of implementation error can you catch, right? So you might need just different parts of the post condition to really help catching each kind of possible implementation error. Okay, so now guys, here is my question. If I have just this particular post condition over here, I know that it can do something. right? Especially if I reassign the owner to be some other object, you can definitely catch that kind of malicious implementation. But now, is this post condition complete? Is this post condition complete? Is it possible to have some other kind of implementation that's wrong? However, we can still pass the post condition. That's my question. Okay, I'll pause a little bit for you to think about. Anybody? Or if you believe this post condition is already complete, you can just say it's complete. If you don't think it is complete, you have to give me one scenario where the implementation error cannot be caught. Anyone? Okay, let me read something over here. So, Gilel, we will not know if the change has been made to other owner as well. What do you mean by other owner? That's a little bit vague over here. What do you mean by other owner? Because over here, you see, we only got one owner, right? There's only one, right? Before the withdrawal, the account is pointing to just this particular single owner. There's no other owner, okay? Actually, the answer for this particular question, that's okay, you can just try. For this particular question here, the answer is already talked about in the slides. So the one I just explained about reassigning this one here, that's something new. So that's why I talk about it just directly, right? So now what can be the scenario where we just cannot really tell by using this particular post condition? Okay, I'll give you guys one, maybe a few moments if you can think about. Anyone? Yeah, don't be shy to be wrong. That's okay. Okay, I got one response from Qiming. Okay, if you change the original name value in the person, you're talking about this person object over here, like change Alan to Alan whatever, good. The post condition violation will not be caught, will not happen. Oh, exactly right. Okay, that's exactly right. So remember in your array copy example, right? So now, let's say this. Let's say now the, let me just say this. If I say run implementation number 2, okay, this will not be caught. On the other hand, the previous one will be caught. Okay, just make it clear to you. Okay, so now over here, let's say the wrong implementation goes like this, right? Rather than simply just reassigning the references for the owner, what we will do is we might say, as Qiming actually suggested, what if we say owner is a string? So we can say append star star star. Okay, so just watch out the color so I can you can see the two different versions over here. So now the second version there, rather than just doing this, right? It's not what we're doing. Okay, we say this reference remain to be the same, but now we're going to modify just this object directly. So what we will do is we're going to say over here, rather than Alan, is going to be Alan star star star. Okay, in that case, according to your notes, right? Because the O owner will still be here, right? The way we cache the post condition will be the same. O owner is still pointing to this particular object over here. However, what about the post state owner? Well, since the reference has not changed, it will still remain to be over here. So we are really talking about the same object over here. So this particular post condition will be trivially true. That's not good, because now that means something bad actually has happened over here. Something bad actually happened, but there's no post condition violation, so that's not good. Okay, guys, any question about this? There's actually quite much information that I just talked about. Let me recap very quickly if you got any question. Otherwise, I'm going to move on to the second version. To recap, we are basically talking about if we only get this, just only this post condition over here, and that one there is only using a reference copy for the owner. So that kind of corresponds to the question there, when would reference copy be appropriate? So this is the scenario, okay? because you know that O owner is actually going to make a reference copy of the current owner in the pre-states. In that case, if you try to reassign the owner to be another object by some wrong implementation, so now you talk about two objects over here between the pre and post states. In that case, this particular post condition can be useful. That's a good side. The downside is it's not complete, because if, let's say, we didn't reassign the reference for the owner, so that means this, the owner reference is really the same between the pre and post states. However, the only thing we changed is somehow beyond the first level, right? In that case, we're actually modifying Alan to be Alan star star star. In that case, well, we cannot really tell by this particular post condition, because the old owner and the current owner are pointing to just the same object. So if you compare the same objects, they are trivially true. Okay, so that's a very quick recap for this example here. Okay, any questions about this? Any questions? Okay, I presume everybody's okay, right? But you can still ask me to revisit this particular example, maybe once you see version number 2. Okay, so okay, apparently the question would be, how can we catch this particular error, right? How can we do it? The answer is we have to do like the post condition that version number 2 is going to catch. Okay, let's see this. So now for version number 2, what I will do is I'm going to cross out this particular post condition from the previous one, right? So now I really want to see if they can survive, independently in isolation. It turns out they cannot, right? So now let's talk about this particular guy here. You know what? If you already understand what's going on here, the way I'm going to explain the story will be exactly the opposite to how I did it in the previous one. But let's do that anyway, quickly, okay? So this one here, so now if you look at the post condition here, equal person. And what we're doing is we're in the pre-state, we should really catch a deep twin, like a deep copy of the owner. That's what we're doing, right? So now what we are doing is basically something like this. So now when we try to evaluate, let's just talk about what the wrong post condition might be, okay? The wrong implementation, sorry, not wrong post condition, wrong implementation. The implementation that version number 1 cannot catch is this, right? Let's talk about that one. So that one there, let's say the wrong implementation will simply just be the owner in the owner dot append star star star. Let's say that's the wrong implementation, and can it be caught by this particular post condition? I will claim that it is. It can be. That's also one of the example you did in the lecture. Let's do that very quickly. Okay. So now what it does is, so first of all, when we try to catch the pre-state value, what we're doing is O expression will go with this particular deep twin, which means we are deep twinning just the owner. So the owner is really pointing to this particular person object, right? So now that means we got old owner deep twin. So that one there is really pointing to a new person object over here, right? Brand new, completely independent structure. And then that one there is really name. And then it will be recursively actually deep twin, so right? And then it's also going to be another Alan string object over here, completely deep twin. Okay, so that's the caching process. And now we're going to execute the wrong implementation over here. What that will do is it's going to append. So you can see the owner, current owner is pointing to this particular person object, right? And then it's going to append. Actually, it should be owner.name. Okay, over here. Owner.name, the append. So that will be Alan, star, star, star over here. All right. So now when you evaluate this particular post condition over here, if you compare, so owner will now be Alan star, star, star. And what about the caching value? It will still remain the same over here. Oh, sorry, let me say it again. So when you say owner over here, it's going to still point you to this particular person object, which has Alan star, 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 right? And then when you talk about the caching value, it will still be this deep copy over here, which has the name Alan. So you can see their names are simply just different. So it's going to be false. So it will be a post condition violation, which is good. Okay. So this one here for the wrong implementation is going to be caught. Okay, so it will be a post condition violation, which is good. However, the next question will be, will this particular post condition alone be enough? Well, it wouldn't be enough because every post condition may have its own limits to what extent you can really catch. Apparently, if you only get this particular post condition, you will not be complete. Exactly the scenario that the previous post condition over here can actually handle. Because in the previous one, if you try to reassign the owner object, it will be able to catch. But what about this current one? Can it catch it? Can it? Why don't we take a look quickly for those of you who may not be clear. Let's say we got another wrong implementation here. And that one there is simply just going to say owner is assigned to maybe just some new person. Great. Person, let's say, again, Mark. It's not really correct syntax, but you can see what I'm doing. I'm just saying Mark over here. Okay, so now what I will do is the caching will still be the same. Okay, the caching will just be the person object, right? So now, if I simply try the following, if I simply reassign this particular object over here, there will be a way for me to simply do this. I'll just give you one example over here. So now, owner, rather than pointing to over here, it might simply just point to just the same object over here. It might be. In that case, when you try to check this post condition over here, it will just be the same objects. So it wouldn't be caught. So in order to really catch it, you will need this particular post condition over here from the version number 1. Okay. So basically, you want to think about whatever that can be caught in one version is the limitation for the other version over there. And this one can catch, that version cannot catch. Okay. It's a little bit of quite many details over here you want to think about, okay, and then digest. So that's something you want to watch out for. You know, it can get tricky. Okay, any question about this?
Professor, just a quick question.
Go ahead, yes.
What kind of questions should we expect for quiz 2? Should we expect this kind of questions? Because
you know what, anything is possible. You know, to be honest with you, in the Q&A, I'm not really concerned about what question you're going to be asked. It's already there. It's being fixed since last Friday. So I think my concern will be if you really understand what's going on here. That's why we are running this session here,
no,
right?
That makes sense. But I was just wondering because these are kind of long, so.
Yeah, you know, I tell you what, if I really put, for example, right, assuming that you understand this, so I would say mostly the quizzes will just be multiple choice, right? You might be matching the answer. You might be selecting whatever answer is true or false. If I do put this question here on the quiz, I might say, I might give you the wrong implementation there, and then I'll simply ask you, can this particular post condition catch that? Yes or no, right?
Okay.
Something like that, yeah.
Okay. Thank you.
No problem. Yeah, guys, you know, I know that you're very concerned about the quizzes. I'm concerned too, right? But I'm more concerned about your learning as well, right? So do your best. All right. So any more questions for me about this particular question? All right. All right. So now just another, I think that's the last one from the Google Doc. After this, we can do some simple exercises for the contracts. So they can just clarify more confusion maybe from week number 1 as well. And this one here, your fellow student was asking about this. So this is more like version number 5 from the bank account example over there, right? So that's version number 5. Okay. So that's the final version there. Okay, that one works. You can also play with the source code I gave to you. So now your fellow student was suggesting this particular cross notation here, this one here. They were basically asking whether this will work or not, okay? I don't want to get into a little bit too details because very specific, you know, thinking. that they are thinking, their thinking process over here. But let me just help you understand. Let's say your colleague actually maybe discuss with you whether this will work. How should you really see the essence for this particular post condition? Let me give you some hints here. Basically, you can see there are two across loops, so it's nested, right? The first, the outer across loop is going across the old version of the accounts, right? It's a deep twin. You can think about this is really going through the accounts in the pre-states. Okay, so what you would do is you can think about if this is the current layout for the entire accounts, right? The bank, right? So what the pre-state will do is you simply will just duplicate the structure. I will just draw very quickly, okay? Something like this. And that one there is going to point to two accounts over here. Actually, just the account, no bank. So that one there was simply, okay, it's going to deep twin the accounts array. So that one is going to point to an array of size 2. And then it's going to point to account number 1, account number 2, right? Completely independent. So that's deep twin for the pre-states. And then they also try to go over the accounts, which is the post-states. You can think about this is the pink one, right? And then when they say across over here, so when you say across and across, so what does that really mean? I would say I don't even need to look at this particular logical structure over here. I would say this one is like overkill for the performance because they're using a nested loop. Think about what, let me give you one analogy here. Writing this is pretty much like writing this. If I say across, let's say 1, 10 is I. And then I will simply just say loop, okay, just make it easy for you, okay? But the same idea will apply to, when you use all or some. And the second one here would be across 1 until, let's say 5 here is J. And then we say loop over here. Okay, we got N here, we got N here. Let's say we simply just want to see, somehow we got I, we can use I, and we also can use J over here, right? So now I have a simple question for you. If you try to run this particular loop over here, how many iterations are you gonna do? How many? 10, 5, 15, or something else? I times J, 50. I think Jun Yang, that's good. That's exactly right. So actually nothing conceptually new, guys. It's basically just a nested loop. Because if you see the pattern over here, so when I is equal to 1, so if you look at the pattern I and J over here, when I is equal to 1, J can be from 1 to 5. When I is equal to 2, J can also be from 1 to 5, and etc. Right? So it's going to be the upper. So this size over here will be 10. The size of this range here will be 5. That's why 10 times 5, that'll be 50, right? So that's the effects when you got nested loop, a nested across or nested loop here. So now when you are doing this particular cross loop over here, I would say it's overkill because you are something that could be done linearly, you're doing that quadratically. So what's happening here is, so when you go across the pre-state, you're going to say, when I talk about this particular count, I'm going to check against this. When I got this one here, I'm going to check against this and this. And when I got this particular account, I got to check against this and this. Even though the logic here might be okay, but I would say performance-wise is already an overkill. Also, it also complicates the matter. So that's my quick feedback to whoever is asking this question here. Okay, so it would just be unnecessary. So that's my comments to you. Because you pretty much know what you really want to try to check is, if this is the pre-state array, I should really try to compare element by element in the position-wise manner, right? Index 1 against index 1, index 2 against index 2. I could have done that just linearly. So doing that quadratically, again, is unnecessary. It's too excessive, okay? All right, so that's about the week 2 lecture materials. Let me see, I got one question from Jun Yang, okay. Is it necessary to across old accounts the deep twin rather than just accounts the deep twin? So Jinya, so here you can see that it's actually different. I think what your colleague was really meant to do. When they go across this particular expression over here, you can see this one here, right? So this one is really going across the old version, like a pre-state version of the accounts. And then when they go across this account over here, so that's the post-state version over here. The advantage of using old accounts, the deep twin over here is, if you try to make any changes as you learn from the lecture, for example, if I simply change this maybe to -5, so now if I compare in the post condition, I compare this account over here against this one here, they are not equal, so I will get the post condition violation. So I would say if you want to compare to see if the intended change, to really write a complete post condition, number one, the intended change should be there. For example, you should really deposit maybe 100 into Steve, for example. Not only that, the rest of the structure shouldn't change. In that case, you want to make sure this account over here is equal to this account here between the pre and post state. That's why all that deep twin will be necessary. Okay. All right. Any more question related to week number 2? Okay, good. All right. Since that everybody is okay with week 2, okay. So why don't we spend a little bit more time just about the exercise I gave to you on week number 1. So it might be nice to talk about them briefly. Okay. So we got 1, 2, and 3. I think each one of them does talk about some nice details about how you should write a contract. So it might be nice to talk about them. Given that you guys also got more experience about writing contracts at this point, so you might be in a better position to judge. Okay. If you haven't looked at the exercise, that's okay. So why don't we look at that now? Okay. So now the first one here, I will go over that with you and I'll pause in order for you to respond to me, right? It may not be so interesting if I just tell you what the answer is, so you wouldn't learn. Let's say we have a query here called is positive. Okay. Is positive, which will take one input, I of type integer, that returns a Boolean. Okay, it's a query. And then let's say this. The implementation is simply just I larger than 0. Oh, sorry. The implementation is going to just assign the result to be I larger than 0. Seems to be all right. Okay. And now the post condition here, I simply say I larger than 0. Okay. Given what you have over here, do you think the current design is actually okay? Okay, I'll pause a little bit to see anybody want to either speak up or maybe type your response on the chat. Okay, I see some good response from Caleb. Okay, so now, so hopefully so far now, if I ask you this, maybe in week number 1, maybe you wouldn't be able to tell, what the flaw is. But now, if I actually, but now given that you have more experience, so now you can see what a fix should be. First of all, let's talk about, I can tell you that the fix should be, the fix should be, it should be fixed into result is a Boolean, right? If and only if I larger than 0. That should be the fix. For you to actually somehow work out what the fix should be may not be so difficult. But before I talk about it, why is the current post condition wrong? I think that's more important to realize. It will compile. Compilation is not an issue because this is a Boolean expression, which is completely fine for the post condition. So what's really wrong when I write this post condition here? Why would that be wrong? Can anybody give me some scenario where we should expect some post condition error, but it didn't happen, and where we shouldn't expect, but it happens, right? Jalel, you said, what if I is equal to 0? You want to lead me to this? Want to speak up, Jalel?
I was just wondering what if the value of I is equals to 0, then
sure, no problem. Let's try. Okay, I will. You can help me out. So let's say, what if I is equal to 0, right? So now it's positive, it's going to be, we call simply just 0 over here, right? Well, mathematically speaking, 0 is not positive, right? Because positive only means from 1, 2, 3, and so on.
Yeah.
So now we know that in this case, result is going to be assigned to, so 0 larger than 0 will just be false.
False.
Okay, and then what?
Then, are we going to get a post condition error or?
Why? Okay, post condition violation. Why? It's on a good track, but why? Why would we get a post condition violation?
Because in the post condition it says I should be greater than 0.
But now in this case, this specific input is not greater than 0.
Yeah.
So that means we're only going to, very good, thank you. So if we evaluate this, it's going to be 0 larger than 0, and then it will be false. So that means, so guys, you see what's going on here? Even though result will be assigned to the correct value, however, there will be a post condition violation simply because the post condition is simply saying the input you pass must be larger than 0, rather than saying the result should be assigned properly. So that's the problem. All right? So that exactly right. So now that's why the fix should be result. Another way for you to think about, some students may like to think in this way. You want to say something like this. I'll show you a different way to write this. You can choose the one you really prefer. I'll tell you which one might be most preferred for your learning. Okay, you can either say, for example, you can say input I is larger than 0. That implies result is equal to true. You can do another one. So case number 1 should be the case, and case number 2. When I is less than or equal to 0, that implies result is equal to false. It's more like a case analysis style. However, I would suggest at least when you say result is equal to true, it's as if you said simply just result, because result is simply just Boolean, right? And also when you say result is equal to false, it's as if you said not result. Okay, hopefully that makes sense. That's solution number 1. Okay, that's number 1. And number 2, I noticed that a good number of you try to do in lab 1, try to do if then else, right? Another way for you to do it is something like this. You can say if, let's say this, if I larger than 0, and then basically I want to create an if then else expression such that it will return a Boolean. So that means both branches for the if branch and also the else branch, they should both be Boolean. Okay, so now this should be a Boolean, and this should be another Boolean as well, right? That's the structure. A very common mistake you might have made in lab 1, if you try it, let's say if you simply forgot about the else part, you simply say if something, then some Boolean without the else part, is going to be considered as a compilation error. Because if you try to do if then else as a Boolean expression, you must have always the else part. Otherwise, the runtime wouldn't really know what if the else condition is actually true. In that case, what value should they return, right? Okay, anyway, just an aside. So now for this particular if then else over here, so now we can fill it in quite easily, right? So I would say the most compact way to write this would be if I larger than 0, it would be just result. Otherwise, not result. Okay, that's approach number 2. Okay, I would say approach number 2 may be the least preferred. I wouldn't so prefer that. I tell you why. Not just because I don't like it, but I think when you are writing for contracts, you better think more logically. I would say if you still think in terms of the if then else, you're still having the programmer's mindset. So it may not be so ideal. So I would suggest you may want to use the logical operators as much as you can. Okay. Okay, and then we have another approach over here, another one. So that's basically what I said as the original fix. So now we can say result if and only if I larger than 0. So this will be the best format over here. But I would say if you can already come up with number one, you might just ask yourself, can I possibly simplify this to say result and not result? And then it simply corresponds to either I larger than 0 or not the case, I larger than 0. So that's simply just equivalent to number 3 over here. Okay. So now 1, 2, or 3 are all acceptable. Okay. You can choose either one. And the main thing to pick up from here is every time when you write the post condition for a query, you are supposed to involve the result. Okay. All right. Let's see this. Should we have a precondition for this particular query? So who's asking that question there? Okay, so now for collab, what kind of precondition do you need? If you say we need a precondition. Are you there? Hi, yes. Oh, you want to type, or if you don't feel like speaking out, that's okay. So I'm just asking, because you were asking me if we should, if we need a precondition for this routine over here, right? So what kind of precondition do we need? If you want to suggest one. Let me give a little hint. Remember last week in the Q&A, we talked about the difference between total function versus partial function, right? And now it's positive. It's basically a function that simply takes an integer and returns a Boolean, right? Should is positive a partial function, or should it be a total function? That's really the question, right? So collect, what you're asking is, should we put a precondition here? If you put a precondition here for is positive, you're suggesting that it should be a partial function, meaning that there should be some integer value that we should forbid, we should disallow to be passed as input for is positive. What integer values are you thinking about? Yeah, anybody else can also try to answer, if I got any thoughts. We are trying to make some design decision over here. Should it be a precondition for is positive? That's what we are saying here. Zero or less than 0. Not really. Okay, so you're suggesting this. Hypothetically, you're really suggesting this. If I say require I less than or equal to 0, I believe that's what you meant, right? Okay. What's wrong with this particular precondition? Anybody? I can tell you that it's definitely too restrictive. Yeah, Junyang, you only accept 0 or yeah, actually true. I think maybe Colette meant to say was, maybe you meant to say this way here. Well, doesn't matter. Either way works, okay? Let's say if I put this particular precondition over here, so that means according to Junyang, I'll just follow the same. You're saying that you require the input to be always larger than 0, or the other way. If you say I less than or equal to 0, will be the same argument. Let me talk about this one here. If you say I always require I to be larger than 0, so that will be a partial function, right? So not all the integer can be the domain, right? Now, so let's see why this would not be good. So that means you only allow is positive to be called on positive number. So that means now if you may say 2, you may say 3, you may say 4. So that means the is positive will always return just true, always. But what about some other value you may want to expect to return false, right? You're strictly forbidding them. So you shouldn't put any precondition over here. Okay, good. Yeah, so I think that's a good question there. I think it's always good for you to think about. For a particular routine you're trying to design, you may think you might need some precondition to begin with, but it turns out that precondition there will actually disallow certain input values that should be allowed. So that means your precondition here is too strong. Okay, in this case, it should be a total function. Okay, all right. Okay, guys, that's the first exercise. I hope you got the idea here. So hopefully you also learned something from here. Okay, second one. Again, we also talk about is positive, right? Just something you're familiar with. Let's say over here is positive, and then I say x is of type integer parameter, and also it returns a Boolean over here. So we got case 1 and case 2. Okay, you can read it over here. Okay, and also case 2. Okay, the same question. If you're given this particular design over here, especially just for post condition, and we know that there shouldn't be any precondition, okay? Is this appropriate or not?
It will always be false because one of them will be false.
Okay, Bian, okay, you said you will always be false. You want to help everybody with an example.
If x is greater than 0, then the first case is true, but the case 2 is false.
Okay.
And conjunction of them will be false, and otherwise the first one
will be okay. That's very good. Okay, that's pretty spot on. Okay, guys, Bian is actually exactly right. Let me help you a little bit if you haven't followed that. Okay, so now think about, given that this is a total function, so that means x can either be positive or it can be non-positive, right? Now, let's talk about two cases: positive, non-positive. And for each one of them, I'll just give you some example. If I say is positive, and then let's say 3 is positive, right? And then we know, let's assume that even, let's say the implementation is simply just correct. So that means we're expecting true. We're expecting, right? However, when we try to evaluate case number 1 and case number 2, let's say case number 1, when we evaluate it, we're going to get 3 larger than 0, right? X will be 3. And result, let's say result has been calculated correctly, and true is equivalent to true. This will be true. So case number 1 is fine, okay? And then for what about case number 2? For case number 2, x is actually 3 less than or equal to 0, and also result, which is true, is equivalent to false. Apparently, you can see this is false, this is also false. False. So that means we're going to get a post-condition violation. Even though the result is calculated correctly, but we get a post-condition violation. However, as Bian points out, it's actually worse than this. It doesn't dysfunction just because it's when it's positive case. It dysfunction always. Okay, let's try another branch over here. Let's say if you try to pass on non-positive number, let's say is positive over here. Let me just make it very obvious. Let's say -3. Okay, just negative, right? So now what about case number 1? Well, case number 1 is interesting. It will be violated right away because now -3 over here, larger than 0 is already false, right? And also the result in this case will, of course, it will be false, the result, right? And then false equals true, also is false. So we still get false and false. We still get a post-condition violation. Okay, can everybody see it? So that's a problem for this particular post-condition here. I think in some way the tags are very informative. Well, in some way it's case 1 and case 2, right? Maybe you should say positive case and negative case, something like that. But now the problem is it doesn't matter what input you give over here, you will always get post-condition violation. So that's not right. So now, how can we fix this? Any suggestion? How can we fix this? Okay, Ziwei, you said, can we just change n to implies? Yeah, actually, I would tend to agree with you. You're saying that to fix it, rather than n over here, we're going to say implies. I agree with you. But now, I think not only that you should really know this is how you fix it, right? Because I don't want you to just memorize, you know, whenever n doesn't work, you just do implies. When implies doesn't work, you do and. That's not the way to go, right? You want to understand why. The reason that this one actually wouldn't work, the original one doesn't work is this. for any given inputs, right? You just cannot expect. You remember we said implicitly when you got two cases for the post condition, it's really this really like an implicit end, right? Like every new line is like an end, right? And now if you simply get n and n, you're really saying 3 should be larger than 0 and less than or equal to 0 at the same time. It's almost like saying p and not p, which is always false. That's the logical flaw of the original post condition. So changing this to implies will definitely help. Now, let me just do one for you, okay? Why would this be okay? Let me just do the easy one. Let's say we changed it to implies already. Let's say we have done that. So now, given that we have done the change, so now when we try to evaluate, let's say, again, let's say it's positive. Let's say -3, okay? The same over here. Let's see how we can get by that particular violation we got before, okay? It's +3, -3. We know that result should be assigned to false, right? That's the expected result. So now when we evaluate case number 1 here, for case number 1, so x larger than 0, so in that case -3 larger than 0, we know that it's false, but bear with me. So that one implies result which is false, right? Is equivalent to true. So now it's actually quite trivial because we know that this already is false. And according to the evaluation rule for implication, if the antecedent is already false, the entire implication will just be true. So that means this is the case where antecedent is simply not satisfied, so we just let it go. And the way we let it go is to just bypass this particular post condition. So we can go to the next one. Okay, if you go to the next one, if you go to case number 2, in that case, you're going to get this, -3 less than or equal to 0, and then that implies over here, result which is false, is equivalent to false. So this would actually work because -3 less than or equal to 0, that's actually true. So now when the antecedent is actually true, the truthfulness of the implication depends on the consequence. So now false equals to false will also true, right? So you really get true implies true. So entirely it should be just true. So that'll be okay. Okay. So this one here actually really illustrates very nicely the difference between implication and conjunction. You don't necessarily always have to use implication, but you have to know when to use it. Okay, that's the main lesson here. Okay, any questions? Okay, everybody's okay? All right. All right, so final one over here. So this one is actually easier, I would say. If you look at this particular one here, again, we also got is positive, right? Just the same example. And then we got input, also we got output, right? Now, we say ensure. Okay, we got this. Okay, is there anything wrong with this particular post condition? Anything wrong with this? Okay, that's pretty good. So Caleb said, I mentioned that we cannot do this because whenever you want to use the if then else for Boolean expression, in that case, you get a compilation error. Very good. Jaleel and Caleb, I'm very happy. You did listen to me. That's good, right? So what we will get from this over here will be a compilation error. Because you only got the if part, you don't have the else part. If I want to put the else part, I can say else result is equal to false. So this one pretty much corresponds to approach number 2 I mentioned over there, right? So of course you can also try the other 2 approaches as I mentioned. Okay, so this one is very easy. I think just make sure you don't really write anything that doesn't compile. All right. Okay, so that's about everything I have for your week number 2 questions, and also for something I left off from week number 1. Okay, any question related to lecture materials? So everything is clear to you, I hope? Yeah, I suppose you attend because you think you might ask me some question, right? So about the lecture. So feel free. It's your time. Okay, so I suppose everybody is happy just about the lecture. All right. Okay, so in that case, should we call it a day? We can end the session earlier if there's no further questions. All right. Yes, I saw something on the chat. Yes, I'll read it. What about let's see here. Caleb, you want to say something? How to enter the office hours. So, Wei Ming, I think you can simply go to the lectures page, and then on the top you will see a Zoom link to my office. I think that's how you get to my office. Good. So I can expect to see you then. Good. Okay, let me see the collab. Let me just read your collab. Are you referring to? Is positive? That's what you're referring to, right? Let me see. Why can we not do result larger than 0 instead of result I? Are you talking about just the post condition? Yeah, result is Boolean. Okay, and then I don't quite see what your question is. Can you declare a local variable under ensure section? No, you cannot. The only way you can introduce, there are only two ways you can introduce new local variables under the ensure clause. There's only two ways. So let's say you have ensure. Okay, ensure over here. And then let's say there are two ways. I'll show you both. You have known them already. Approach number one, if you got across, right? Across certain iterable range over here, and then over here after the is, this is where you can introduce some new local variables. That's one way to go. Okay, so here this could be some new variables across all or across some. Another way to do it is you might say attached. Attached, maybe certain expression over here, right? And then you can say attach as, and then this one will be just another local variable. And of course, every time you say this, you're going to say and then, right? I already explained what and then really means. So that's really using a short circuit like a ampersand in Java, right? And then over here, for the rest of the conjunction, you can just use that variable there. So these are, as far as I can recall, the only two ways you can do it. If you're thinking you just want to declare local variable, for example, under ensure, you just want to write local over here and do something here, no, you cannot do it. The reason being, when you are doing post condition, it's really just about specification. So it's not about implementation. So if you declare local variables, it's just too implementation oriented. So it wouldn't be allowed. Good. Okay. So Junyang, responding to your question, yeah, you're right. So of course, okay. So if you try to use if then else, if you're going to use the if then statements in the post condition, right, it's going to return a Boolean. So if you only say if then without the else, in the context of either a precondition or post condition, it's going to be a compilation error. Okay, so to really resolve it, you have to say else part for sure. Okay, so that's basically what I said. Yes. On the other hand, if you try to write if then else in your implementation, you may have a missing else. That's okay. But in the context of the post condition, you must say what does it really mean when the if condition is not satisfied. So what should be the return value for the Boolean? Okay, anything else? All right. Okay, so you know my how to get to my office hour. So I got my office hour between 4 and 5:30 this afternoon. So you can still speak to me. If you got some specific code you want to show to me, that's okay. Just welcome to come. Otherwise, yeah, I think that we might just end the session slightly earlier, but we'll still use up almost 18 minutes already. So that's good. So for those of you who haven't finished the lecture for week number 2, you should really finish them. I will encourage you to really finish them before you try the quizzes. I think that's highly recommended. Okay. Yeah. So yeah, if you got any study problem, please get in touch with me early. Otherwise, yeah, I'll see you later. So let's call it a day. All right. I'll see you later.